We'll be talking about standard deviation today, okay? And there's two types of measures of variation. It's variation from the mean or median or whatever you want to call your average. Okay, the standard deviation is a measure of how spread out numbers are. Its symbol is lowercase sigma, okay? And the formula is easy. It's the square root of the variance. So now you might be asking, what is the variance? The variance is the average of the squared differences from the means. That's a lot of information. So here's the step for actually doing it. Steps for finding the variance is work out the mean, the simple average of all the numbers. Okay, then for each number, subtract the mean and square the result, and this is called the squared differences. Then work out the average of those squared differences. And you do need to know that there's two versions of this, and we're going to have to be careful to pay attention to the fact that there might be a sample or a population. Okay, and we'll talk about that on the next page. Alright, so for the first one, here we go. Okay, so we're going to add up everything. Alright, so what we did was we found the average, so this is the first step. So we found the the mean, okay, and that's going to be 7.22. Now the next one is that we're going to actually subtract that from each number, okay? So here's how it's going to look. Okay, so the first one's going to be negative 2.22 because this is what happens when you go 5 minus 7.222 repeating. Now obviously I didn't include a whole bunch of the decimal places because these would be really long. So this is a truncated version of what standard deviation should be. Normally standard deviation, you don't want to screw up this insanely too much, so I strongly recommend this is just for the sake of space on here, but just understand that these are repeating 2's, and these ones right here are going to be repeating 7's forever pretty much. So just so you understand that, that's what these are. So each one of these is just the subtraction of it. Okay? Alright, now what we're going to do is square each result, and here's what we're going to get. Okay, so this is what it's going to look like. Everything's squared. Obviously, this is with the non-truncated version, so this is the numbers we're actually going to use. Okay, now we're going to actually calculate the sum of all these. So we're going to calculate the actual variance. So we're going to do the sum first. So the sum is going to be this. You should probably say this is all the squared differences. Let's put some space in between those. Okay. Alright, so that's the square differences. So the sum is going to be this. Okay. Alright. And then what we're going to do is we're going to divide by 9, and we should get this. Okay. Alright, now if we did do the standard deviation, okay, we would just square root that top number, and so we would just go square root of this number, and what we would get is something, and we would probably truncate it a little bit. 4.049 is what I would probably use, and that's what you do. Now please understand, variance is always going to be smaller than standard, or is always going to be bigger than standard deviation because it's the square of it. Okay, now if you'd like to use a calculator to get this information, feel free to go ahead and use it. This information is actually from a great website, mathisfun.com, but I've actually shown you how to do this and actually calculate all this stuff to be able to do it by hand in case an EMP wipes out all your electronics. Okay, the one great tragedy I see a lot of students do is they accidentally screw up these two. And whenever you screw up the variance, you definitely screw up the entire thing. Okay, now here's the thing. Okay, you would use 9 if you're dealing with a population of information, if you were dealing with the whole population. Now if you were dealing with just a sample, you would change this to 8 for the sample because you go 1 less than what is actually given. Okay, so if we actually change that sample, okay, if we change that sample to now an 8, what's going to happen is our variance changes. Okay? And now we are dealing with a whole different type of square root, which is going to be about 4.294. Yeah, let's leave it at that. Okay? Alright, so just definitely changes it. So be careful if you are dealing with a population or a sample. Okay? It's just that important that you guys need to understand. Let's go back. Oof. Population. Okay. Alright, the difference between a population standard deviation and a sample standard deviation. Okay, because the sample is always going to be n minus 1 as the number of terms underneath, and then right here. So you can do the same steps here, but then when you get to about step 3 and then you're going to do variance next, you need to be careful about knowing what you're dividing by. Okay, that's it for standard deviation. Once again, use a calculator if you'd like, or do it by hand. I'm totally cool with whatever. All right, you guys have a wonderful day, and I'll talk to you later.